Hi, Assalamualaikum. My name is Atira Suraya binti Azman, and today I'm going to present to you our assessment 6 for last week. So as you can see here, this is the diagram that is drawn based on the questions given. And here we can see there is a three data table which we rename to the TC type, process plan, and analysis. So what is the data table represent? This data table represent the number of containers. As you can see here, the first step is we duplicate the container 4 times and we rename to the TC type 1, TC type 2, TC type 3 and TC type 4. This container will be dragged to here and we will get the user objective TC type 1 and so on. This frequency is given in the questions and we rename the container name to the TC type 1, TC type 2, TC type 3 and TC type 4. Okay, back to the model. What is the process plan data table? Process plan data table is actually a direction where this container will be going. This is their instruction. Okay, so as you can see here, the TC type 1 will be going to the DIP1, DIP2, DIP3, and lastly, the container will be going to the DIP4, which is the last direction here. And following is the TC type 2, and this is their direction, BCD1, BCD2, RAD1, RAD2. And the TC type 3 will be going to DIP1, DIP2, VCD1, VCD2, and CIN. And the following is the TC type 4 will be going to DIP3, DIP4, RAD1, RAD2, and CIN. Okay, so this is actually the direction, okay? Right, so here the analysis is the output for the arbitrary layer and blockade. So this is the output later will be discussed with my partner. Okay, so in this conveyor, we have 10 conveyor here that are linked from the source to the drain. So this 9 conveyor F1 until F9, we include the sensor so that every the parts here will be sensor will be activated when they sense the part is here. So the sensor will be send the part according to their method. Okay, as you can see here, the F1 have the sensor here. So we double click, we see on the user define. Actually, we already defined here. We're using a method for the sensor to sense the required parts to be sent on the required machine. Okay, so we open and this is the coding. So the coding here indicates that if the TC type 1 or TC type 3 is sent here in F1, then the parts, the container will be transferred to the buffer 1. So how can we know about this method? Well, actually, it depends on the process plan, the one that we already instruct the parts to go. Okay, so back to the model. F1, it says that TC type 1, TC type 3 go to buffer 1. Buffer 1 is here, the IP1. So we check the process plan. We see TC type 1 and TC type 3 go to the buffer 1, which is the machine is the IP1 here. So that's the reason why the method only indicates to the TC type 1 or TC type 3. And why the sensor the method is not indicated to type 2 and type 4 because these two container are not going to the IP1 as you can see on the table. Okay, so the buffer, what is the function of the buffer? Okay, the buffer is actually if the machine here, the IP1 or any of these machines is occupied, the product will be waiting in the buffer. Okay, so back to the conveyor on the F2, we can see here the user define is on. We define the name is on, which is we on the sensor, and then it will go here. If the TC type 1 or TC type 3, then transfer to B2. Why? Again, it's because of the process plan. So buffer 2 is the DIP2. We see in the process plan, we have DIP2 here and we have the DIP2 here, TC type 1 and TC type 3. Okay, so same goes on the F3, F4, F5 until F9. So as you can see here, for the F3, we already put the method. So we open. So in this case, if the sensor detect the presence of the TC type 1 or TC type 4, then the part will be sent to the buffer 3. If the sensor is not is detect other container beside these two, then the container will be passed to the next conveyor, which is the conveyor F4. Same goes for the every conveyor. Okay, so what happened to the parts that is in the machine, the IP1, the IP2? Because in the earlier, I already told you when the sensor sense the presence of the specific specific container, it will be sent according to the instruction in the process plan, right? Okay, so these parts that already in the workstation, what happened to them? Okay, firstly, we're going to double click on the DIP1. In each workstation, we also already put the method. Okay, so as you can see here, we rename it as exit. Double click, and we can see that the instruction is after the part is already done in the each of the designated workstation, this product will be sent back to the conveyor. In this case, for the DIP1, we send the output, the process part in the DIP1 towards the F2 for the next process. Same goes to the DIP2. We already put the method, so the part will be go according to the instruction given. So we already said the product will be moved to the F3 after the process is already complete in the workstation DIP. So the process is the same for every workstation. If they are in the IP2, it will be sent to the conveyor S3. If the parts in the IP4, the output will be sent to the F5, and so on. Okay, for the MSIM, this MSIM is the method which is we instruct all the parts to be follow according to this analysis. Yeah, according to this instruction to the coding. Okay, so I think that's all for my part.
Assalamualaikum and good day. My name is Anishaira binti Johari. So I will present the flexible production line model or assessment 6 that we have completed. Basically, continue from my partner explanation, I will explain on the moving ways of the part at the workstation and the conveyor, and also the result of the model. So to make the part or the transportation container that named as TC type 1, 2, 3 and 4 to move, we have to add another method at each workstation. The method is add at the user defined named as exit data type method. The coding is add.move F2. F2 is the conveyor that basically named as F1 to F10 at in this model. So workstation 1, we required to move the part to the next conveyor, which is F2. The same goes to each workstation until the end of the workstation pin. So we will see at the workstation 2, the IP2, the same method is defined in the user-defined exit. The number of conveyor is changed to F3 because workstation 2 will move the part to the conveyor 3 to continue the process. So to make sure that the moving is in control, we will need to make changes at the control of each workstation at the exit. To use the define method, we have to add the exit by selecting object exit. Exit is the user-defined method we have prepared previously. This one. So adding the exit, then we can apply and then okay. So the same goes to the DIP3, DIP4, RED 1, RED 2, VCD1, VCD2, and also pin, so that the part will continue move from F1 to F10 before they goes to drain. So after running of 8 hours of processing time, this is the result. There are a total of 299 printed circuit board that will go to the drain, which is TC type 1 is 66, TC type 2 76, TC type 3 79, TC type 4 78. Beside of the result of the pieces of printed circuit board that go to the drain, we can also see the analysis of each workstation by the data table analysis that we prepared earlier. So at the data table, we can see the percentage of working, empty, and also blocked of the workstation for the whole 8 hours. So it will show the DIP1, DIP2, DIP3, DIP4, RED 1, RED 2, BCD1, BCD2, and also pin workstation percentage at the analysis data table. So the result will be displayed at the end of the process. This analysis is obtained through the coding that we prepared at the NSIM. Basically, the NSIM coding or method is to print the result analysis by showing the working, blocked, and also empty of each workstation. So you can see this analysis 1 is the IP1, the IP2, the IP3, and until the last workstation. So that is the explanation for this whole model. Thank you.